Welcome to Tech Combos YouTube channel. First of all, thank you so much for subscribing to my YouTube channel and its Facebook page. In the previous video, I have published the presentation about history of computing. My aim on publishing that video on history of computing is not only to highlight about different historical invention, but also I wanted you to have a feel of what was the need for these inventions, why inventors were looking for other options, how other inventors were influenced by their previous inventors, how the idea or design has been implemented, what was the drawback, etc. etc. Why I am discussing all these is that from my personal experience, whenever I design or develop any program, these ideas helped me at a good extent. In the same way, you be as a computer science student or a software professional, I would like you to feel the essence of ideas of our earlier inventors so that it can help you in your work. Let's move on. Necessity is the mother of invention. When the need for something becomes essential, you are forced to find ways of getting or achieved it. These are the buzzwords which I highlight here, which you can relate in a later point in the session. Let's discuss about manual mechanical computing. Though there were multiple devices invented during this period, it requires intensive manual effort to carry out basic operations. Now, I will quickly discuss about something more important takeaways on each invention. Abacus. Everyone believes this is the first calculator used for simple calculations. What I wonder in this device is that the idea of coming up with base 10 and base 5, which helps us in considering bigger values for calculations. Also, I like the design of storing or keeping the current state of computing. Napier bones. It simplified and increased the speed of doing multiplication and division, and reduce the risk of error in large multiplication. Napier's greatest contribution was the invention of logarithms. Logarithms were quickly adopted by scientists because of various useful properties that simplified long, tedious calculations. Logarithm to base 10 is called common logarithm and has many applications in science and engineering. Binary logarithm is a logarithm with base 2 and is commonly used in computer science. Slide rule got developed using the concept of Napier bones. It is a very simpler version of a calculator to perform multiplication and division. It also supports 3 to 6 decimal points. Pascalin. Pascalin invented this machine for his father. He is a tax collector. It is the first business adding machine. 10 teeth were represented to represent 10-digit number. Digit is selected by rotating the appropriate teeth until metal stop is reached. Pascal's calculator was especially successful in the design of its carry mechanism, which adds 1 to 9 on a dial and carries 1 to the next dial when the first dial changes from 9 to 0. His invention made each digit independent of the state of others, enabling multiple carries to rapidly cascade from one digit to another regardless of the machine's capacity. Step reckoner. First mechanical calculator to perform all four arithmetic operations. The step reckoner expanded on Pascal's ideas and did multiplication by repeated addition and shifting. He is the inventor of binary arithmetic, which is essential to the modern computers. Leibniz was a strong advocate of the binary system. Binary numbers are ideal for machines because they require only two digits, which can easily be represented by on or off state of a switch. When computers became electronic, the binary system was particularly appropriate because an electrical circuit is either on or off. Birchen loom. Basil Bochan was a textile worker. He had partially automated the tedious setting up process of draw loom in which operator lifted the wrap threads using cards. He has automated it by inventing a way to control a loom with a perforated paper tape. This development is considered to be the first industrial application of a semi-automated machine. 3 years later, his assistant Jean Falcon expanded the number of cords that could handle by arranging the holes in the rows and using a rectangular cards that were joined together in an endless loop. I am relating here loops which we use it in programming languages. Jackwood Loom. Jackwood brought together Bochan's ideas of continuous punched roll and Falcon's ideas of durable punch cards to produce a really workable programmable loom. Punched cards inspired Babbage to use these punched cards as an input in analytical engine. The idea of punched card data storage later adapted for computer data input. Analytical engine. First general purpose computing machine. It distinguishes computers from calculators by introducing a conditional statement. It has a module design of having multiple components to take care of specific tasks. Like mill takes care of arithmetic computation, store takes care of store the data and results, operational cards takes care of feeding the program instructions, variable cards takes care of feeding the input data, and output takes care of printing the output in the punched cards. This is the first design for a particular purpose device that can be defined as a Turing complete in literal terms. We will see what is Turing complete in the next slides. Analytical Engine supported a range of performance sources like digital format, printed copies, punch cards, and chart plot. Recap on manual mechanical computing. Calculations were performed by moving the beads up and down on the abacus machine, assembling the Napier bones as needed, moving the strips as required in the slide rule, rotating the gears on Pascal machine. Bochan loom, though the design was programmed as a pattern in the tape, still it required an extra operator to control it. Levers and gears were used for operating the analytical machines. Challenges in manual mechanical computing. Inventors were still looking for an improvement to avoid manual interaction, process more jobs, and also speed up the processes. Electromechanical computing. After the invention of electricity, inventors were trying to use the electric components such as switches, relays, rotating shafts in building electromechanical calculators and computers. Let us discuss about some important takeaways on each invention on this area. Tabulating machine. Designed to assist in summarizing the information stored on punched cards. Developed to help process data of 1890 US census and helped in reducing census duration from 8 years to 2 years. Punch card is popularly used for other business applications like accounting and inventory control. Herman Holrich founded a company which later became IBM. Turing machine is a hypothetical machine thought by a mathematician Alan Turing. Despite of its simplicity, the machine can simulate any computer program no matter how complicated it is. Is a mathematical model of computation that defines an abstract machine which manipulates symbols on a strip of the table according to the table of rules. Turing is widely considered to be the father of theoretical computer science and AI, artificial intelligence. And Ethereum Turing complete, Bitcoin is not. So, what is the Turing complete? You can look forward for the standard definition in the Google, but I will try to simplify the same here. A Turing complete means a system in which a problem can be solved by iterating unlimited number of times, accessing random memory, and stop the process once it finds a solution and print the results. For example, HTML and SQL were not Turing complete. Why? Because by design it has no looping constructs. Please explore more on Google to get more idea about this. Z1, world's first program controlled computer, could perform all four arithmetic operations. Instead of using gears and wheels to represent the 10 decimal digits, ZUs decided to build a fully binary computer and used mechanical gates and mechanical memory. The machine was supporting floating point number as well. The Z1 contained almost all part of modern computer. Example, control unit, memory, microsequences, floating point logic. Only the logical unit was not realized and input devices. There are multiple consequent inventions like Z2, Z3 were invented by ZUs. Harvard Mark I. The main advantage of Mark I was that it was fully automatic. It didn't require any human intervention once it started. It was mainly used in war effort during the last part of World War II. A program loop was accomplished by loop unrolling or by joining the end of the paper table containing the program back to the beginning of the tape. Literally, it creates a loop. Colossus Mark I. Here I would like to highlight the first computer bug. Grace Hopper is one of the primary programmer for Mark I. One day, Mark I was malfunctioning and not reading its paper tape input correctly. Hopper checked out the reader and found a dead mouse and its wing blocking the reading of the holes in the paper tape. She removed the mouse, taped it into her logbook, and recorded relay's malfunction due to bug. Henceforth, the term bug was used to describe any errors or glitches in a program. Recap: Electromechanical computing. Punch cards were used for feeding the data into the system, which reduced the workload for the US census. Mechanical calculators computers were invented where to perform calculation it doesn't require manual input. Challenges in electromechanical computing. Inventors were still looking for an improvement to avoid high power consumption and speed up the process. Electronic computing. After the advent of advanced electronic components, computing became cheaper and made possible to common people and were able to carry thousands of instructions in a second. Let us discuss some important takeaways on each invention on this here. ABC. First truly electronic digital computer called Atonov-Berry computer, ABC. This computer used a circuit with 45 vacuum tubes to perform calculations and capacitors for storage. First computer used binary math. Arithmetic logic functions were fully electronic, implemented with vacuum tubes. Logic gates were used in performing arithmetic operations. It could add 30 addition or subtraction in a second. ENIAC. First general purpose electronic digital computer that was used in World War II. Large in size and consumed lot of power. ENIC was a module computer composed of individual panels to perform different functions. 5 generations of computer. Please have a quick glance on 5 generations of computers. Thank you so much for watching my video. I hope you would have got few things out of this video. I will strive to share the knowledge what I gain and I feel it can be helpful to others. Thanks once again. Please subscribe to my YouTube channel and provide your support.